everyone, and thank you for joining today's webinar, New Trends in Production Compliance, Human-Centered Design, Simulation, and Ergonomic. Please know that you have joined as an audience member and are muted. My name is Madeline, and I'm today's moderator, and I'm joined by Curtis, our Director of Technology and Master Presenter, and Dan, our NX Genius and Solid Edge Guru, who will be joining us at the end for questions. So let's begin with a quick overview of our agenda. We're going to start with a little bit about Geometric Solutions, who we are, and how we can help you. And then we'll jump into our main topic, Human-Centered Design, Simulation, and Ergonomic, and how it can help you. This is Curtis, our Director of Technology at Geometric Solutions. He has more than 30 years of experience in manufacturing, technology, and has been at the forefront of digital simulation, specifically related to virtual prototyping and dimensional quality. He's recognized internationally as an expert in digital simulation using 3D tolerance analysis simulation tools, and he has experience using all the major CADs, PDMs, CAE systems, and multiple digital simulation applications. And as you will see, Curtis enjoys the blending of new technology, software, and best-in-class processes, all while driving the need for quality, resulting in the reduction of overall costs. And then let's jump into the quick introduction about Waltonen and Geometric Solutions. Waltonen is a family made up of 3 companies located throughout the Midwest, which is Waltonen Engineering, Independence Tooling, and Geometric Solutions. And our story is pretty simple. Waltonen develops innovative engineering solutions using Siemens software. We got so good at it, Geometric Solutions started selling the same potential for success in the form of Siemens software. So when it comes to implementing and optimizing these solutions like an expert, Geometric Solutions can get you there. And with that, I will pass it on to Curtis. Curtis, go ahead and take it away.
Great, thank you. So one of the things that the owner of our company says, you know, our ability to successfully partner with our customers comes from our experience in using the tools we sell every day. Waltonen Engineering, you know, we have a couple hundred desktops that we use these tools, and that's one of the reasons we think we're successful at this. So let's get into it. Human-centered design, simulation, and ergonomics. Well, what are some of the challenges our customers face? You know, for product design, you know, the customer experience, the people that buy the product, how do they experience? How do they feel? Reach, clearance issues, you know, and design for population. And when I say that, you know, the 5% small female and the 95th percent large male is different across the globe. And we want to make sure products that are globally sold fit the market and the people that are using it. And it all comes down to that customer experience. Are they happy using it? If they're not happy using it, if they don't feel right using it, it makes a big difference. So that's some of the challenges we have in product design. But when we start looking at manufacturing, you know, we're worried about injury and mitigating the risk of that person getting injured working on the plant floor, from lifting up too heavy of a load or reaching too far. You know, the flow of the process, how do people work and can they get to it and the timing for it? And we just want to validate that they can actually do their work and do it safely. You know, and then, you know, with this new situation we're all in right now, you know, with social distancing and everything else, returning to work and employee safety is a big item. So we want to worry about that. And then lastly, you know, training. You know, we can use tools like this to actually do training and make sure that everybody understands what they're supposed to do, how to do it, and to do it all safely. So with these challenges, you know, there's some trends that are going out there for simulation. And, you know, there's static simulation. Basically, can you reach, you know, it's more of snapshots. Ergonomists, you know, have professional tools, and they actually tracking workflow. You can actually see the footprints there where people are working, how long it takes, you know, how much effort and work goes onto it. Regionalization for different countries and different populations inside the company. Product design, making sure the product is comfortable. You know, everybody's been in a car that they go to reach for the radio knob, and they actually have to pull their back off the seat to reach it because it's too far away or uncomfortable. And, you know, people sit in cars and they don't like that feeling, they may buy a different product than that one just because it didn't feel right. And then there's all types of safety and compliance. We want to make sure the people on the plant floor are safe and they have healthy work atmospheres to work in. And then big things nowadays is some input and display devices. We can do this through AR or VR goggles. There's ways to do motion detection with suits and gloves and trackers. So we're going to talk about all of these a little bit here. So first question we have, poll question here. Have you ever bought something and thought the product design was not made for a person your size? And this one's a multiple choice one, so pick as many as you feel is applicable. Well, that just shows there's different populations out there. Some of these questions were aimed for people like me. I'm 6'4", a little overweight, well, maybe a lot overweight. And, I don't fit into, I used to years ago go to the auto show to see what cars I fit in, not necessarily the cars I wanted to buy. Nice thing is I know I'm not going to have to buy and pay for the insurance on a Corvette because I don't fit in them. But there's other things that happen to people when they buy things. I just know my back hurts from going to the kitchen sink and washing dishes in the sink because I have to bend over to put my hands in the water, and if I do that for a long time, my back hurts. So not everything is made for everybody. And if I'm a product designer and I'm designing products, can I make products that make sense for everybody globally and fit the full market? I'm going to add one more comment here. I used to work for General Motors, and for a while I was working on the Saturn vehicle, that first Saturn vehicle that came out. And right next to me sat this nice young lady. She was, I think, 4'10" and probably about 90 pounds. And every now and then they'd grab the two of us and have us go sit in the mock-up and basically say, can you fit in there? And we go, yeah, but it's uncomfortable, but we could drive if we had to. And they said, good, we hit the mark, because they were going for the 95th percentile large male down to the 95th percentile small female. We were just outside of that. And, so they had their market that they were going after. But, when you get into other vehicles and other products, you want to make sure everybody can use it and feel comfortable doing it. So there's a portfolio of products that Siemens has, and they have Jack and 4 different, and they call it Jack, the human simulation tools. They've nicknamed Jack and Jill, Jack for NX, and it's really focused on product design. And there's a lot of things for occupant packaging and feel. So whether it's in a car or just grabbing a coffee pot to pick it up and how comfortable you are, that's what it's all around, was designing the human, the consumer, and their comfort. But then we have a tool called Process Simulate, which is focusing a lot of the manufacturing end of the business. And it has a lot of focus on task analysis and motion capture to make sure that the people putting things together are putting them together well and can do it safely. There's another product called VizJack. It works on Viz Mockup and a few other of these visualization tools that Siemens has. It's the more basic set of the tools that are out there, and it rides on top of, if you have Teamcenter, it can actually be deployed through Teamcenter. And then lastly, Classic Jack is what they call it, and this is a standalone product. And this product can kind of do it all. This is meant for people that are doing product design, existing people that are using NX. This is meant for folks that are doing manufacturing only, have tools like Process Simulate. And then what the Classic Jack one is kind of a standalone tool that just does it independent of the other environments that it's sitting in. So let's talk about these tools and what they can do and some of the special features. So all of these have global databases of different people in the 95th percentile tall and small people. And I'll show you that, but they all have that capability. The NX version and the Classic Jack version basically have where you can actually go and alter those and change those values if you really want to. Posture prediction, which is kind of unique. And like I'm going to pick on this car here. You put where the feet need to be, you put where the hand needs to be, and it'll try to figure out where the body wants to posture itself to fit those conditions. And it actually predicts the posture. Comfort assessment, how comfortable you feel as a consumer using it. But then we start getting into forced positions and brace positions and leaning over and these other unique positions that people get into when they're assembling parts and to see if they can actually put it together. I was actually involved in a situation many years ago where it was for a aircraft fighter, and they wanted to see if somebody could service something under the deck where the cockpit is, and they actually had somebody crawling inside a hole in there and another person holding them by the ankles, and it was a very forced and awkward position, but the military signed off on it because it could be done by somebody, and it was awkward and ugly, but it saved the exterior styling because otherwise they'd have to put a hole in the outside with an access panel, and they didn't want to do that for stealth purposes. There's human performance tools, how well people perform, specifically the standards, and there's a bunch of standards out there, and we'll review a few of those. Task simulation, the task of go to this point, pick this up, move it, so you're giving tasks to a human, and we can simulate that and have that drive how the human reacts. Motion capture, there's different types of motion capture tools that are available out there. We work with most of those. And then lastly, the AR or VR goggles that are out there nowadays. Process Simulate's the only tool right now that has it integrated. It's moving over to Classic Jack, it's just not there yet. Classic Jack kind of does it all. Jack for Annex does a lot of the product stuff. The manufacturing stuff is focused on Process Simulate Human, and the BizJack is more of a simplistic tool, but depending on what you're trying to do, it works great. So let's just talk about Jack for product design. So, what we're trying to do is validate design for a specific regional user group population, or maybe a global population. Accurate kinematics ensures accurate reachability and clearance assessment, and visual realism for issue communication, talking to folks. But we can pick from different standards of populations. In North America, the answer standard is a very common one, but we have a database for Korean, Chinese, Canadian. There's a few other standards out there that we can grab. And then who is the person in that area? You can't see it, but it says male or female under here. Yeah, are they at the 50 percentile of the population? Are they a little overweight? Are they underweight? You can try all those combinations and see how it all works. But we can create and edit humans to test for populations. That's the big thing. So here is a quick little example of it. So here I'm grabbing the 95th percentile male at 95% weight, and I'm going to create this human. So what it does is create that human, other people, different sizes and shapes, so I can test all these different values of folks using whatever the product is that I'm trying to designate. I can actually modify these people. I can actually have preset positioning, so it helps me put them in action in the mode that I'm going to be in, and then fine tune it. So here is reaching for a mirror inside a car. Golfer's bend. There's multiple ones here. Pullback, right? So we can actually preset them in these positions and then tweak them to make it match the exact tools or the applications that we're trying to do, but it helps us get there. Note, these tools have all 206 bones of the human body and the limits and linkages of them. So how that back bends and all those vertebrae put together are all inside here. And we have stressors and joints on there, and we'll talk about that more too. So another tool that's available in here is what they call a reach zone. So from where that person is standing, where their elbows are, their shoulders are, as they reach out, we get a couple of cones, and it makes sure that we can reach things and it's comfortable, and I'm not stretching and bending my body to get to things. So the goal here is just to quickly, reach, develop this envelope to make sure, controls or whatever it is I'm trying to interface with are easily accessible by the human, whether it's a consumer buying a car or on the bottom left, somebody working on a tool inside a plant. Comfort. All right, so now we have comfort. So again, I was talking earlier about reaching radio knobs inside cars. That's a classic example. Here I have a comfort study for it, and here where the head is, where the shoulders are. When I get into the forearms, it's not that comfortable. When I get into the feet or the lower legs, it's not that comfortable. So I can see where the issues or problems and try to resolve that in my product design and make a product that the consumer is happy with versus hoping they're happy with it. Posturing. I was just showing you some postures that are out there. There's a series of predefined ones. What we do is we put somebody close into that. I can actually start configuring the hands. But one of the cool things in there is what they call this inverse kinematics. I basically put on the machine, the tool, the part, where the hand needs to be. I tell where the feet are anchored, and I say, put that hand there, put the other hand on the other side if I wanted to do that at the same time. And it figures out how to make the human reach it. So that's very cool because as the parts move dynamically in your design, the human has to adapt to it. And we can actually tell if that's a stressor. And it doesn't make a difference which human it is, which size human. We can test, and that's actually very powerful. And I'll show you how that works in a little bit. Eye views. I can actually look through the eyes of the human being and see what Jack sees or Jill sees. I can optimize placement of critical controls and create designs that avoid blind situation or operations, especially like in assembly. So we want to check that out. But you can see here, here's what the operator's seeing in here. The environment that the operator's in, and I got a left and right eyeball, same thing up here. So let's see what that looks like. So here we have an operator, and I want to see what he's seeing. And I'm going to set the eye windows up here. And when I set it up, it's going to set up one, then another, and there's a couple different versions of it. So here I got a left and a right eye. I'm going to have a middle eye that just gives me one view, but I can see in stereo what's happening. And as I pull the person's head around and move it around, I'm seeing exactly what they're seeing. So I can see if that position, they can actually see the object that they're working on and touch it and feel it and get to it to make sure they have the right, capability to know what's going on. So like in this case, we're going to put the eye views for Jill here, and I want to make sure that she can see the crank that she's cranking on and the release mechanism at the top. I can just check all that out by just moving her head around to make sure she can see it while she's in that position. If I'm too close, can I see what's behind it if I need to? I can check all that stuff out from the operator or the consumer's point of view through their eyeballs inside Jack. This doesn't sound like the most glorious part of the tool, but they have these disembodied hands. It's a unique thing, but it allows us to quickly test for hand clearance and accessibility without the need to posture the entire body. So I can have hands and I can have hands with forearms and make sure they can do things. So let's just see what this does. So here I happen to have a hand. I can put different grips into them, pose them already into different grips. I can do specific modifications of the hand as needed to match whatever the object is I'm trying to work and operate on. So you can see I'm actually picking on the joints, modifying them to do what I want it to do. And I can actually do testing with just hands and such. So here, the gripping and feel of this power saw. Can I get the 95th percentile large male's hand inside there or not? I can test for that. Here I have a motorcycle. I want to see on the grab hand, the handlebar up there, that a person's hand can actually go in there and grab it, feel comfortable with that pull lever there, that they can reach it, no matter what size the person is or their hand, to make sure that it is acceptable to all, so I can reach that for the product design. Here I'm actually doing service. Can I take this pipe out and can I get my hand around it to uninstall it or install it, depending on what the situation is? So I want to double check that. I can do that with this tool. and I don't need to have the whole body. On the other side, I just want to be able to remove the spark plug, and I want to see if my hands, my fingers can actually fit inside there and get that out. Is there enough clearance that I'm not making a pinch point or impossible for a human to do that? So we can check all those things with a tool like Jack to make sure I can do it with this disembodied hand. Here, if I'm doing service or maybe just installation, I want to make sure I can get my hand in between these plates and put something together or take it apart without pinching it or just having access at all. So this is a great tool, these disembodied hands, to actually do quick and simple tests to just see if it's feasible to do what the task at hand is. I was talking earlier about posture positioning. It allows you to evaluate the combination of large and small individuals from your target user population, and it is very powerful. So let's take a look at this and some of all these things that I've talked about in this little quick video here. So here I have the interior of a vehicle, the small vehicle, and what I want to do is see how people fit and interact with the vehicle. So I'm going to come over here and start putting some base data information in, make sure I got the right size vehicle, and I'm putting in, some high level vehicle criteria here, where the wheelbase is, how far apart it is. You can see those little blue dots, those are specific points in a car design. Center line of the column, the H point, which is basically the hip point of the person sitting in the seats, heel points. Those items there help develop whether or not I can design a car. And traditionally, they've made these points in car design for decades. It's something that's been standardized, but now it's done electronically. But now that I have that, I can actually start testing out how people would be able to sit and feel when they sit in these vehicles and is there room for them. So I can actually start putting in these human models. So let's go over here and add the human models. And the first thing I want to do, this is a small car, the first thing I probably want to check is if a guy my size can actually fit in it and feel comfortable or, would enjoy the car enough to buy it. So I'm going to pick the grouping of people that I'm going to be using for this test. I want the 95th percentile, which is the larger, 5% is the smallest. Weight, 95%, so I'm at the high end of the weight here. So, what is this person? And this is the height of the person in scale to the car. So we want to see if this gentleman can actually fit inside there, but at the same time, I want to pick a smaller woman to fit in there. And let's just see. Now she's at the 50-50, percentile weight and size, but of that smaller classification of size. Let's see if they fit inside this vehicle and how they compare to each other. I can do that too. So I'm going to do the predict posture. I'm going to put the person, I select him. I say where his feet's got to be. I say where his hands got to be. You can see that in red, and it puts it into that position. So now he's sitting in that position, holding the car. I didn't have to do anything other than tell where the feet and the hands went. And it determined the positioning of that, along with the H point there. So that person's sitting into it. The seat hasn't moved back. It's in the same original nominal position. But I can do that now for the woman. And so now what I'm going to do is put her in the driver's seat again, just like the last person. Get the placement of her hands and feet. And it will determine where she's going to be. So I actually have the two compare to each other. It's, it allows you to actually see, compare, and the seat can move up. We want to make sure the seat would move up to her. The tracks will allow that. But based on the feet and hands, that's where her body would want to be. Here's her spine. I can actually see the spines between the two different bodies and how they relate to each other. So you can see the hips are basically on the same plane of the seat. They're just not in the same place front to rear of the vehicle. So I can actually see them. So now what I want to do is take her and I want to move her to the passenger seat. So I'm just going to come over here and identify her and say she's going to be on the passenger front right. And the hands and feet move over to that position. And there we go. So I can actually display them next to each other side by side so I can see how they all are. So you can see the viewports of his left and right eye and see what he can see as he rotates around, and actually see that he can see the instrument cluster through the steering wheel the way it's positioned. Because sometimes I actually did interior designs for cars, and that's one of the things we had to study manually was eyesight of the instrument cluster and the clearance through the steering wheel to get to it. And we had to make sure that was available for everybody at different heights and different applications. And here we can do it using Jack to make sure it's all clean and good. So, got another poll question. Do you see value making sure your customers globally can use your products?
Looks like we had a consensus. Yes, we want to get larger market share.
Yep. See, now if I would have answered that, I may have answered that last one because that's always been a pet peeve of mine is, even the product I own right now that I drive every day, I have to lift my back off the seat because I'm tall and my seat's all the way back, and I have to lean forward just to turn the knob on the radio. And, it's just an aggravating thing. But, the goal here is to get a bigger market share, and excluding people does not get you a bigger market share. All right. So, basically, business is about winning. Your company wants to win. What we're trying to do is make a plan for winning and make sure you can win successfully with a well-developed plan and tools to enable you. So let's jump into manufacturing. So before I was talking about product, but we have to make these products and make sure our team that works for us are safe, healthy, and happy. So here we have a situation where we're assembling batteries. So nowadays everything's battery operated, So here I'm actually showing the task. So he had a go command, and we're going to get a get command here, and we're telling him he's going to go get this. And the human software is actually figuring out how to make them get there. So you can see the go, the actual steps, the footprints are going into place. Did that also for the female. She goes to reach, and look, she can't reach that far away thing, and 800 millimeters to or just 300 short. So, that's a big reach that somebody has to overcome to get there. So let's just look at some analysis here. So if we start looking at the rapid upper limb assessment, the RULA, how is my upper limbs doing? He's getting a score of 6, which is right on the edge of dangerous. I mean, it actually is dangerous because it's a little more orange than other. But if I just did something as tilt the table up, I can test this. Can I reach it? Yes. Can both of them reach it? This is great. I can do that. Now I'm actually looking through her eyes. She sees him go up there. This is the one center eye, as I call it, the third eye. That's not a left or a right. It's a composite view. And yes, she can see it. She can reach it, which is great. Let's look at the study for this. And, I'm in the 2s and 3s. I'm in green. I'm looking happy. But let's actually get into the ergonomic analysis. And we start looking at the elbow. 72 pounds or newtons versus 62. She's right on the edge of potentially having a injury over time, because if you do that every day, it's kind of like tennis elbow. It can, happen to people over time just because it's on the edge of being comfortable, and it hurts them, as they repeat it every day, day in, day out. So we can evaluate that again, or, make a little step stool or a little platform that you can get up on to reach it. Many ways to solve this problem, but there's a problem and you're trying to make sure everybody's safe. In an assembly work cell, walk actions can represent hidden costs, including unproductive time or increased chance of part damage due to collisions with surroundings. To help better analyze the walk requirements in a work cell, we can create a comprehensive analysis of the walk actions and basically report a graphical spaghetti diagram of the walk path, and just a tabular summary of the time and distances that it takes to do things. So, I get this output to know how much value added is going on with the people and how much time it takes and how that affects my production throughput. There's a human copy command, which is kind of great. When I'm simulating scenarios with multiple different, you know, size figures and just taking the task, I can just quickly copy the anthropometric and postural information from one figure to another, and it just saves me tons of time, right? You can easily select, like to copy their posture, their sizes, and force information between figures. It can be copied either as joint angles or more flexibility by using the task goal option. I'm using my task to get how I'm going to define it. And, I can restrict, it automatically restricts non-compliable selections. So things that can't be done, it'll tell me this. If it's up high for the male that's taller, it'll tell me that the female can't reach it. So it's kind of nice because I can actually make sure anybody can work at that station or do that task. And I only have to do the figuring it out once, and then it's more of a copy paste for every other size. Arm strength, right? Strength capability is a central component of a comprehensive, I can't even say comprehensive, ergonomic evaluation, helping to identify musculoskeletal overexertion injury risk, as well as providing guidance on such things as assembly force limits. The arm strength evaluation tool basically provides insight for strength-related assessments in contrast to models based on strength of isolated muscle groups. So we're trying to basically, how, a lot of the other tests we have is how well muscles will perform, but here is it enough strength to do the task on a regular basis, especially when there's some type of, exertion or force that I have to do. So it also considers hand location and the direction, the orientation of your body and the strengths of your muscles, and gravity, So, this is a great tool. And then you can then test it for different size populations, just make sure that everybody can do that task, and then make sure ergonomically they can by either giving them aids or tools, or, sometimes it's just simple as a platform or a table that moves up and down so they can adjust it to their own personal preference. So here we have an example. Here I'm doing a reach study. I want to make sure I can reach everything. So each arm is there. I can see that. So, I'm looking at the person that I made. This is a large male. It's at the 95 percentile range, and he's reaching over to pick this up. And I'm checking his lower back. And, how did that hurt bending over and digging into that? So I'm going to specifically, interactively check the lower back in the simulation so it gives me instant feedback. So I'm going to reach over here, grab this, and, I can see the limits where he's at. For him, it's okay. I'm checking limits as they're bolting things on. The low back's great, it's fine. Picking up a tool, the tool doesn't hurt anything. The carried weight doesn't hurt anything. So I'm actually finding out he's not doing too bad for this task. I can see he's getting close to a problem because this is during that whole task, I tracked everything. And I just want to make sure he's doing great, which is phenomenal. Now, I also know I worked in the plant for a while. A guy my size can pick up heavier parts, and I can do things a little differently than other folks. So here, I can actually got the weight of the part as part of my CAD data, and it's telling me that. And if it was an assembly, it would let you know that. But let's say I change my person. So I went to a female, and I went to, no, we'll just keep it here. But which database I'm using. Once I pick that, then I can actually say, well, she's at the 5%. She's at the very small end, and she's very thin. So let's just check to see how this person is. So this human replaces that human, and I'm now just doing the same task. So I'm going to check strength and back because I'm concerned about that. And as I can see here, she's bending over. I'm seeing what the data is. Long story short, when I get done with my simulation, I can actually see my results, and I can see whether or not she can do this. So here's Jill's results, and in this case, she can. So we made sure they can do it. And that could be something as simple as that dunnage, that container that was holding those parts could have had a drop down front edge to allow easier access in versus bending over. So I can test all that stuff out in the simulation tool to make sure everybody's happy, healthy, and safe. So have you ever had, or your company ever had, any type of ergonomic injuries from your plant floor?
Looks like our top answer is we test that prototype and adjust and redesign to make it better.
Yeah, that's quite common. You know, when you don't have an upfront plan or tools to simulate this stuff, it's the only way you can do it. You can put it on the plant floor, somebody get in there. I've seen it happen 100 times, and they start going, that's kind of, that's kind of sore, that's kind of far, that's kind of, and then they redesign things, and that's not when I should be doing it. When things are hitting the plant floor and I'm actually doing production or starting my production, I don't want to have delays because I got to have special tools or special containers made or boxes, like that tilt table I was showing you for that battery. Making that a tilt table was not an easy task. And if I had to do it at that point of the game, it would have been much tougher or more expensive to do. So, but the goal here is, we want to make sure injuries that could be avoided. I can analyze this and predict these things over time. The repetitive stress of doing it day in, day out, will it hurt? And I can predict that with these types of tools, not just, the first time they use it, but every time they use it over time. So one of the other things, there's motion tracking tools. There's multiple setups that we work with on different types of tools, from lighted cages to trackers to all types of things, even that data glove. And it's an immersive environment to author, review, and collaborate with the human inside the tool. So let's take a look at this. So here I have a gentleman wearing trackers. You can just see they're Velcroed onto his body at different locations. And you can see on upper top area is the tracking software that's piped into the simulation software at the bottom. And I can actually see what the operator's doing and how they're doing it. Cool thing is it's scaled to the person. So once I know where the trackers are, it actually knows how far things are apart and can then determine what size person it is, which makes it easy because I don't have to fuss with that much inside the tool. Another thing we can do is, that was a kind of a larger setup where I had the legs and everything, but I can just do a partial thing. So here I just have a couple of hands. I got a human moving this around. I can have them testing this. It's sometimes a lot easier to show how this is working with a simple tracking device and having somebody sitting down at a piece of plywood on a chair or standing next to it with a couple of boxes around just to test it and make sure they can do everything they need to do. Then I can actually go into the software, make some changes, do some testing, and then allowing the human operator to play with it some more. So I say the human operator, the person that we're actually testing are doing the tracking on. So, it's kind of cool that I don't have to do the whole thing. I don't have to have a whole setup. It's, I can get into it very cheaply and affordably. One of the other things we can actually use this tool for is, what's the best process? If I considering replacing a human with a robot, is it value added? Can I, do I get the value out of it? For the volume, is it, if I'm making thousands of parts a day, maybe my robot's pretty, cheap. But if I'm only making a couple a day and it's a part-time job, the human's a lot cheaper because I don't have all that upfront capital costs. So I can actually test for interference conditions between the two types of, scenarios, where they're human, whether they're hitting anything, or a robot. And, I can just make sure I have the best solution. In addition, depending on what I'm trying to do with today's environment, I can enable social distancing with this. I might be able to replace a person to make sure they're safe and move them somewhere else in the plant to make sure that they're not violating any social distancing rules. So let's talk about that. You can see cylinders around these people, but returning back to work after this COVID-19 scenario, how can we do that? So here I have an example where some people are assembling some parts on a drill. They're sitting next to each other. Parts are coming into the station, and they're walking back to an assembly line. And, this was the pre-COVID-19 scenario where they were close to each other, which back then didn't make that much difference. But now, how can we make sure they're safe? So I can put 3-foot radius bubbles around their heads and see if these bubbles interfere with anybody, because height makes a difference and in distance. So right now they're violating the 6-foot rule that we're trying to keep. And, as they walk away, it's fine. But when they get next to each other again, so right now we're failing our social distancing. So what's great is now that I have this simulation, I can test for other types of ways to do this. And I don't have to do it the old way. So I have another design here. I'm going to pull it up. And everybody's been in the stores now. They got plexiglass between cashiers and you and such. So maybe that's what we do is we put cashiers around them. Everybody has their face mask and their dust mask on their, you got a face shield and a dust mask. I put plexiglass on the sides of them and in front of them. I have an opening on the bottom, a little tray, and they can actually do their work. And I'm going to run the simulation here. And as they do the work, this gentleman here on the bottom here is just going to bring a tray past and actually reach underneath, grab those, and pull them away. So they're not getting next to each other. It's added another person for labor because this person now is doing the transportation. But those 3 workers are sitting there safe. They're not violating any distance rules. And, it's one way to do this analysis is, I could simulate it if I had the tools available for me. To the point of something as simple as setting up your home office, making sure that you're safe at home, let alone, inside the office, or inside the plant floor. I can actually make sure everything's within reach. I can make sure everything, excuse me, is safe. So I can actually do different tests. So you noticed her shirt just turned yellow because her ergo score is down in that position. Purple is good, yellow is not. She's bending over all the time to reach. So we can actually do some basic ergonomic rules of, make sure, you're at the right position so your arms are straight and they're not bent down or below elbow level, your hands are below it, and, just trying to test it out. The monitor's at the right height, even the right distance, we can make sure that that is true. And, and for lack of better terms, we want to make sure the coffee's always within reach. So here we're doing a distance test. You want the monitor at arm's length away so we can actually test it, move it. This is simplistic, but it just shows the point that we can do this to make sure that, whether it's for somebody at home or somebody at on the plant floor, they're doing it and they're doing it safe. So I have a reach, so I can make sure I can reach my mouse, my keyboard. Very importantly, I can reach my coffee. So I can do all that stuff in this environment and, make sure I have a healthy work environment at home too. So are your plants ready for people to come back to work after this COVID-19 pandemic?
Looks like we had a tie between yes, we have figured it out, and have not really thought about it.
Yep. So I'm going to take that 40% of yes. The other group is 60%, right? And my friend Kermit here kind of explains it, this is how, some people are planning. They're just not thinking about it. They don't see it. They're not, we want to make sure this doesn't happen. We want to make sure our people are safe. And using simulation tools like this is a great way to do that. So, bottom line, your customers and employees are far too valuable to gamble with safety or comfort. We want to make sure we have successful products that everybody likes and uses, and we want to make sure the team putting it together are safe. Any questions?
Hey, Curtis did a nice job on that presentation.
Thank you, sir.
We've got just a couple of questions. What type of companies are predominantly using this human study?
Well, oops, let me turn this back. Somehow I got turned a little bit here. There's lots of companies using this. A lot of I'm going to say larger companies. I'm going to say like automotive companies, companies that make airplanes, companies that make tractors and cabs that they're in, shipbuilders. They're using it for the product design because they want to make sure that customer experience is phenomenal. But manufacturing wise, there's a lot of mid to small level companies that want to make sure their team is safe, and they're using this to make sure that ergonomically to put these parts together, they're in a great position.
Good. And another question is, the spheres that we saw, does that come with the software, the COVID-19 distancing spheres?
That's a pretty simple thing to add in. We just say around the head, there's a 3-foot diameter sphere or a 3-foot radius sphere, and we make it an object that's attached to the human. So just like a tool, we're just making a sphere that goes around their head, and wherever their head moves, the tool or the sphere moves with it. And we just turn collision detection on, and every time they collide with something, it turns red.
Very nice, pretty simple.
Yep, pretty simple 5-minute tool.